shock occurring when touching support cables connected to a driven stake in the dock, even with the power disconnected, indicates a potential electrical issue that needs investigation. Several factors could be responsible, and a systematic approach is crucial to identify the root cause and implement appropriate solution. Let's explore potential causes and troubleshooting steps, keeping safety as a top priority. Firstly, consider galvanic corrosion. Galvanic corrosion can occur when dissimilar metals are in contact in an electrolyte, such as salt water. The support cables and the driven stake might be made of different metals, creating a galvanic cell. To verify if galvanic corrosion is occurring, inspect the contact points between the support cables and the driven stake. Look for signs of corrosion, such as rust, pitting, or discoloration. Check if dissimilar metals are in contact, for example, stainless steel cables and aluminum stakes. If galvanic corrosion is suspected, consider using sacrificial anodes. Sacrificial anodes are made of a more reactive metal that corrodes preferentially, protecting the other metals. Alternatively, isolating washers can be used to physically separate the dissimilar metals, preventing electrical contact. Secondly, investigate for a ground fault. A ground fault occurs where electrical current flows to ground through an unintended path. In this case, the support cables could be providing a path to ground if there's a fault in the dock's electrical system. Disconnect all electrical connections to the dock, including power, lights, and any other electrical equipment. Use a multimeter to check for continuity between the support cables and the water. Set the multimeter to the ohm setting and measure the resistance between the cables and the water. A reading of 0 ohms indicates a direct connection to ground, confirming a ground fault. Carefully inspect the wiring on the dock for any shorts or damaged insulation. Look for wires that are frayed, cracked, or have exposed conductors. Also, check for any loose connections or signs of water intrusion into electrical boxes or fixtures. Thirdly, electrostatic discharge, or ES, is a possible cause. ESD can occur when the dock is subjected to static electricity, such as from friction or wind. The static charge can build up on the dock and discharge through the support cables, causing a shock. Ensure the dock is properly grounded to dissipate static electricity. Grounding provides a path for the static charge to flow safely to ground, preventing a buildup of static electricity. Consider using anti-static materials in the dock's construction, such as anti-static mats or coatings. These materials can help to reduce the buildup of static electricity on the dock. Fourthly, stray voltage should be checked. Stray voltage refers to unwanted electrical voltage that can be present in unexpected places. Stray voltage can originate from nearby electrical sources and find its way to the dock through the water or other conductive paths. Check for stray voltage originating from nearby electrical sources, such as underwater cables or overhead power lines. These sources can introduce stray voltage into the surrounding environment. Use a voltmeter to measure the voltage between the support cables and the water. Set the voltmeter to the appropriate voltage range, such as 20 volts alternating current, and measure the voltage between the cables and the ground reference point in the water. Contact the local utility company to investigate any potential voltage issues. Utility companies are responsible for maintaining their electrical infrastructure and addressing any stray voltage problems. Fifthly, consider the possibility of a lightning strike. If the dock has been struck by lightning, it may have damaged the electrical system or caused other problems. Lightning strikes can cause significant damage to electrical systems, including surges, shorts, and ground faults. Inspect the dock for any visible signs of lightning damage, such as burnt wires, damaged equipment, or scorch marks. Consult a qualified electrician to thoroughly inspect the electrical system for any hidden damage caused by a lightning strike. Sixthly, electromagnetic interference, or EMI, might be interfering with the dock's electrical system. EMI from nearby electronic devices or equipment can interfere with the dock's electrical system, causing electrical disturbances or shocks. Check for any sources of EMI, such as radio transmitters, cell phone towers, or industrial equipment. Try moving these sources away from the dock to see if it reduces the shock hazard. Seventhly, several other considerations should be kept in mind during troubleshooting. Verify that the support cables are properly insulated and not touching any other conductive surfaces. Insulation prevents electrical current from flowing through unintended paths. Check the water quality for any contaminants that could contribute to increased conductivity. Contaminants can increase the water's ability to conduct electricity, making it more likely to experience electrical shocks. Contact a marine surveyor or electrician for a professional inspection and diagnosis. Marine surveyors and electricians have specialized knowledge and experience in inspecting and troubleshooting electrical systems on docks and boats. Resolution involves addressing the problem once it is identified. Once the cause of the problem has been identified, appropriate remedial measures should be taken to eliminate the shock hazard. This may involve replacing corroded components. Corroded components can create electrical hazards and should be replaced with new corrosion-resistant materials. Repairing ground faults is necessary, which involves identifying and fixing any unintended paths for electrical current to flow to ground. Installing anti-static measures, such as grounding and anti-static materials, can help to prevent static electricity buildup on the dock. Shielding the dock from stray voltage can be achieved by using shielding materials or techniques to block stray voltage from entering the dock's electrical system. Addressing lightning damage involves repairing any damage caused by lightning strikes, such as replacing damaged wires or equipment. Mitigating EMI involves reducing the interference from nearby electronic devices or equipment by moving them away from the dock or using shielding techniques. For galvanic corrosion, ensure proper bonding and grounding. Proper bonding and grounding are essential for minimizing galvanic corrosion and ensuring electrical safety in the dock. All metal parts of the dock should be bonded together and connected to a common ground. This helps to equalize the electrical potential between different metal parts, reducing the risk of galvanic corrosion. Use a properly sized grounding conductor to connect the dock's grounding system to earth ground. The size of the grounding conductor should be determined based on the size of the service entrance conductor, as specified in the National Electrical Code, NEC. Install a grounding electrode system. A grounding electrode system provides a low impedance path to ground for fault currents. The grounding electrode system should consist of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. The grounding electrode should be installed in accordance with the NEC. Bond all metal parts of the dock. All metal parts of the dock, including the support cables, driven stake, and any metal structures, should be bonded together using bonding jumpers. Bonding jumpers are conductors that connect metal parts together, providing a low impedance path for fault currents. Use corrosion-resistant materials. When replacing or installing electrical components on the dock, use corrosion-resistant materials, such as stainless steel, copper, or plastic. Corrosion-resistant materials are less susceptible to galvanic corrosion and will help to ensure the long-term reliability of the electrical system. Consider a dock grounding system. A dock grounding system provides a dedicated grounding path for the dock's electrical system. A dock grounding system typically consists of a ground rod or ground plate that is installed near the dock and connected to the dock's grounding system. A dock grounding system can help to improve the effectiveness of the grounding system and reduce the risk of electrical shock. When dealing with ground faults, the first step is to identify and isolate the ground fault. Use a multimeter to locate the source of the ground fault. Disconnect circuits one at a time to isolate the fault. Once the fault is located, repair or replace the damaged wiring or equipment. Use ground fault circuit interrupters, or GFCIs. GFCIs are devices that detect ground faults and interrupt the flow of electricity, protecting people from electrical shock. Install GFCIs in all electrical circuits that serve the dock, especially those near water. Test GFCIs regularly to ensure they are functioning properly. GFCIs should be tested monthly to ensure they are working correctly. Replace any faulty GFCIs immediately. Use proper wiring methods. Use wiring methods that are approved for wet locations, such as underground feeder, or off, cable or conduit. Protect wiring from physical damage. Run wiring in conduit or other protective enclosures to prevent damage from abrasion, impact, or water. Ensure proper overcurrent protection. Use circuit breakers or fuses to protect electrical circuits from overloads and short circuits. Ensure that the overcurrent protection devices are properly sized for the circuits they protect. Properly sized circuit breakers or fuses will help to prevent damage to the electrical system and reduce the risk of fire. The NEC provides guidance on selecting the appropriate overcurrent protection devices for different types of circuits. When it comes to electrostatic discharge, grounding is key. Ground the dock's metal frame and any other conductive surfaces. Grounding helps to dissipate static electricity and prevent it from building up on the dock. Use anti-static materials. Use anti-static materials for dock surfaces and equipment to reduce the generation of static electricity. Anti-static materials help to prevent the buildup of static charges, reducing the risk of ESD. Reduce friction. Minimize friction between surfaces to reduce the generation of static electricity. Reducing friction can help to prevent the buildup of static charges on the dock. During dry weather, static electricity can build up more easily due to the low humidity. When addressing stray voltage, it's best to contact the utility company to investigate the source of stray voltage. Utility companies are responsible for maintaining their electrical systems and addressing any stray voltage issues. They have the equipment and expertise to locate and correct stray voltage problems. Shield the dock from stray voltage. Shielding can help to block stray voltage from entering the dock. Use a metal mesh or other conductive material to create a Faraday cage around the dock. A Faraday cage is an enclosure that blocks electromagnetic fields, including stray voltage. Ground the shielding. Ground the shielding to provide a path for stray voltage to flow to ground. Grounding the shielding helps to prevent stray voltage from building up on the dock. Install a voltage regulator. A voltage regulator can help to stabilize the voltage in the dock and reduce the effects of stray voltage. Voltage regulators help to maintain a constant voltage level, protecting electrical equipment from voltage fluctuations. Lightning strike damage mitigation requires inspection by a qualified electrician. A qualified electrician can inspect the electrical system for damage and make necessary repairs. Replace damaged wiring and equipment. Lightning strikes can cause significant damage to electrical wiring and equipment. Replace any damaged components to ensure the safety of the electrical system. Install surge protection devices, or SPDs. SPD protect electrical equipment from voltage surges caused by lightning strikes. Install SPD at the service entrance and the critical electrical equipment. Ground the dock properly. A properly grounded dock can help to dissipate lightning strikes and reduce the risk of damage. Ensure that the dock is grounded in accordance with the NEC. Regarding electromagnetic interference, move EMI sources away from the dock. Moving EMI sources away from the dock can help to reduce interference with the dock's electrical system. Shield electrical equipment. Shielding electrical equipment can help to block EMI from interfering with the dock's electrical system. Use shielded cables. Use shielded cables to reduce EMI in electrical wiring. Shielded cables have a conductive layer that helps to block electromagnetic fields. Filter electrical power. Filtering electrical power can help to remove EMI from the electrical system. Filters are designed to block unwanted frequencies, reducing interference with electrical equipment. Other considerations include inspecting the support cables. Ensure that the support cables are properly insulated and not touching any other conductive surfaces. Check the water quality. Contaminated water can increase the risk of electrical shock. Consider having the water tested for contaminants. Consult a marine surveyor. A marine surveyor can inspect the dock for any potential electrical hazards. Regular inspections are important to identify and correct any potential electrical hazards. Electrical safety is paramount when dealing with floating docks. Always follow safe electrical practices and consult with qualified professionals to ensure the safety of the dock. Remember to turn off power before inspecting. Always disconnect power to the dock before inspecting any electrical components. Use insulated tools. Use insulated tools when working with electrical equipment. Maintain a safe distance from water. Avoid working with electrical equipment near water. Wear appropriate personal protective equipment or PPE. Wear appropriate PPE such as rubber gloves and safety glasses when working with electrical equipment. Be aware of your surroundings. Be aware of your surroundings and avoid contact with any conductive surfaces. If in doubt, consult a qualified electrician. If you are unsure about any aspect of the electrical system, consult a qualified electrician. By systematically investigating these potential causes and taking appropriate remedial measures, the source of the electrical shock can be identified and eliminated, ensuring the safety of individuals using the floating dock. Remember that working with electricity can be dangerous, so always prioritize safety and consult with qualified professionals when needed.